So basically, this section is going to be titled The Scientific Method And so my first question is, has anybody ever been outside when it rained? Okay, looks like most of us have been. Jack, can I ask you a question? Do you, when it starts to rain, do you run back to your, like wherever it is, your car where you were at, or your house, or anything like that, or do you just take your time walking?
Most of the time, take my time walking.
Do you? Okay. Does anybody run back to their car? Or back to wherever it is? Okay. Now, the question that I asked you is, does it make a difference if you run or walk back to the spot that you were if it's raining outside? Because if you think about it, if you're walking, the rain is falling straight down on you, if we're accounting for the fact that it's falling straight down. Now, no wind involved. Or if you're running, more of the drops are coming at you at an angle and are going to get you. Which one is going to have more rain that's going to hit you? Yes?
Well, like if it's raining hard, I think it might get you more when you're walking because like you're like the rain has more chances to hit you.
Okay, so you say that walking is going to do which part? It's going to get you more wet? Okay, depend on how hard it's raining, okay. Anybody disagree with that idea? Yeah.
I would say running, because when you run, like it's all coming at you, like not just on top of you, because sometimes it sounds crazy, but drops can miss you. But like when you run, you're always gonna get hit no matter what.
Okay, okay. Yeah, Jaden.
I'd say you're gonna get wet the same.
Okay.
Either way, you're getting wet.
Okay, so if we were going to set up and test this idea, how could we go about testing this? Yep.
When it rains, we can all go outside and see, like start from like the school under the roof.
Okay.
And then like run out and then run back and then walk out and then walk back and see.
Okay, so we could basically, if it was raining outside, we'd all have to go outside. Some of us would have to walk, some of us would have to run, and we'd have to account for who was getting more rain on us. Yeah?
I was thinking like a hose, and like you just spray a hose upwards and see what happens.
Okay, so if it wasn't raining, we could use a hose as our rain source, okay. Now, scientists have to use a specific way to organize and set up experiments just like we thought about. Okay, so the first step in our scientific method is we have to say that we are going to state the problem. Okay, so whatever the problem is going to be. And so it's basically asking a question. Okay, so we're going to ask a question. And the question that we just asked was basically, what is going to get you more wet? Is it going to be the rain from outside that's falling straight on you if you're walking? Or is it if you're running that it's going to get you more rain on you? Okay, so stating the problem, asking a question. After we have that question, what's the next step? Does anybody remember this from last year? Yeah.
Create a hypothesis.
Yeah, you got to create a hypothesis. Okay, so you're going to create a hypothesis. Okay, so basically it's developing, creating a hypothesis. It's what you think is going to happen. Now, if I went around the room, everyone could have their thought as to walking or running, which was going to get you more wet. So which one is it going to be? You have your ideas. Now that we have a hypothesis to our problem or our question, what are we going to do next? What's the next thing that we need to do in the scientific method? Chloe?
Experiment?
Okay, so we are going to experiment. And experiment means to basically test our hypothesis. All right, so experiment. We run the experiment. So when you guys said that we could set up a hose and put it into the air, or a sprinkler, or if it was raining out, we could go outside to test it. All of those things would be experimenting. While we are experimenting, there's a fourth step that we need to know. Okay, what is that fourth one? Yep.
We need to record our data.
Yep. We need to record our data from the experiment. Okay, so we're going to basically be recording and collecting our data. And the last step of the scientific method, yep, it's to draw a conclusion. You're going to analyze the data and give a conclusion to the problem. Okay? Now, our analyzing data should answer the problem that we have. So whatever we started out with, we should be able to answer that problem. Okay? And all of this is called the scientific method. Okay? And the scientific method is an organized way to gather data and answer a question. Okay? So those are the 5 steps of the scientific method. We have to be able to ask a question or state the problem, create a hypothesis that we think is going to be the answer to the problem. We're going to experiment by testing out our hypothesis. We're going to record our data from the experiment, and then we're going to take that data, we're going to analyze it, and we're going to try to come up with the answer to the problem. Okay? Anybody have any questions on those couple of steps? All right, with the goal ultimately being able to solve the problem. So our goal is to be able to, through the scientific method, be able to solve the problem. Pretty easy. Now, let's just quickly break apart each one. So, did you still need it? Okay. I'll just kind of start talking while we get going here. Stating the problem. The first thing that you need to know is that it's observations that are through your senses that you notice, okay? So you come across something and you say, I didn't expect that to happen. Or something that you expect to happen occurs. So if I was to take this Sharpie and I was to let it go, what would you expect would happen from it? Jack?
It would fall to the ground.
Okay. And we know this because of the fact that we've dropped things numerous times, and each time it falls to the ground, just like it did there. But if one time that I dropped it and it didn't go all the way down, you would probably be like, that is interesting. That is unusual. Okay? It's those moments where things don't happen as they are supposed to that causes us to ask a question or to see a problem in something. And so when we start off with stating, so if I take the first one, state the problem, it's when something happens that we don't anticipate that makes a problem. Okay, so that's when we have a problem, is when we don't expect something to happen. So when something happens that we don't anticipate, it becomes a problem. Yep?
Are we writing this too?
Yep, you should. Yep. So all of our problems come from that idea. Something happens. Okay? Each morning you wake up, you don't have a sore throat. One morning you wake up and your throat is sore. Something is unusual. Something different is happening. Okay? The fact that you are looking at two different objects, and one of the objects is bigger than the other one. Say you have a watermelon and you have an apple. Okay? You look at them and something looks different. One is bigger, one is smaller. One is green, one is, and so on. You can figure that out. There's a problem. There's a difference between the two things. With that being said, we then develop a hypothesis. Right? So our hypothesis is our idea that it's a proposed answer to your question. Okay, so it's a proposed answer to your question. Okay, it's what you expect to happen. And these must be testable. Okay, anytime that you have a hypothesis, it has to be testable. We have to be able to run some type of experiment to prove it. And your hypothesis comes from your problem. Okay, so whatever your problem is, you have an expected outcome or an expected answer, and it needs to be testable. The third one is going to be our experiment. Okay, the experiment stage is basically scientists run experiments to test hypotheses. Okay, so we have to be able to do that. Now, this part of it is what you mostly struggled with when we did the paper airplane lab. Because I introduced you to a couple of different words that you haven't had yet, like independent variable or dependent variable or control group. Okay. Anybody remember what the independent variable was? Or another way of saying it is the IV? Chloe, you remember? Okay, so in your paper airplane lab, it was the number of paper clips. But the nice way of, or fancier way of putting it, Thomas, is?
The thing that could change on its own.
Excellent. So it's the one thing that is changed in the experiment. Okay, and so what did we change? We changed the number of paper clips that we put on the plane. Okay, some of you, when we start off, we had 0, then we put 1, then we put 2, then we put 3, then we put 4, 5, 6. The dependent variable, or what we refer to as being the DV, the dependent variable, is what? Clint, do you remember what it is? Or do you remember what it was from the lab?
How the paper affected how far the plane flew.
Yeah. Okay, so it was the distance, right? So it's the it measures the independent variable. So it measures the IV. So in your experiment, when you were taking the paper airplane and you were tossing it, okay, the paper clips were the one thing that was different on it, but the distance that it flew was the way that we measured it. We have to be able to measure the independent variable. All right? And the control group, or what we refer to as being the CG, is what? What is the control group then? Yep.
How do you throw it?
That's an example of one of the things. Yep. What's that? Okay, so it's everything that remains constant. Okay? So in our example, when we were tossing the paper airplane, it was your release, the release angle. It was the environment, wherever you were. We kept it in the hall. It was the fact that you had built the paper airplane the same. Okay? It wasn't a different airplane. Okay? So our independent variable is the one thing that changes. Dependent is how we measure the independent. You cannot have an independent variable without being able to measure it. Okay, so you have to be able to measure it, which is your dependent variable. And then the control group is keeping everything the same. Okay? Any questions on those? Because those are the ones that throw people off usually. All right, moving on. Our fourth step was to collect data. Okay, and so collecting data is the fact that as you run the experiment, you are writing down information that you observe. Okay? Now when you're writing this down, it can be numbers or it could be words. Okay, it doesn't always have to just be numbers. In our case, when we took the paper airplanes and we tossed them, all right, we were looking at the plane to see how far it was traveling. So we measured distance with a number. But if we were doing an experiment where we were looking at how something changes color, like if you add something to another thing, its appearance, does it get warmer? Does it get colder? Does it get bubbly? Does it change colors? Those are observations where you would use words. Okay? So we collect data, and the data is collected through running the experiment. All right? The fifth one, and the last one, is to basically draw conclusions. Okay, so we draw conclusions because of the fact that we now have data that supports our hypothesis or does not support our hypothesis. Okay, so we either have data that does support it or we have data that doesn't. And then based on that, it should answer the problem or the question. We're almost done. Okay, we're almost done. All right, so those are the 5 steps of the scientific method. Now, there's 2 other ideas. I need you to understand the difference between scientific law and scientific theory. Okay? Scientific law and scientific theory. A scientific theory is a well-tested explanation for an observation. So it's a well-tested.
With the following students, please report to the office. Nolan Hattenstein, Timmy Wilcox, and Jaden Groen.
Well-tested observation that repeatedly answers a question, but it is never proven why. Okay, so we don't know. A theory doesn't, it helps to explain why something is happening, but it's not something that happens every single time. Okay? The scientific law part of it is a statement that summarizes the patterns. So it's a statement that summarizes the patterns that occur. So if I tell you that this marker drops to the ground, okay, I could say that every time that I throw the marker up, the marker comes down. Okay, that's a law. Okay, I'm explaining to you that what's going to happen. But it's not explaining the reason why that it happens. Okay? And a scientific theory becomes then well-tested observation, but it's never proven. So I can tell you, I think this is what's going to happen, and every time that I throw it up, it comes down. My reason that I think it's going to happen is because of gravity. But it still hasn't been tested or not proven to be the main reason why. So scientific law is just the statement summarizing the patterns. The theory is more of what is the reason for it, or explaining why it's going to happen. And the last note that you need to know is models. Models. Yep. So we use models to represent things that are too large or small or complex to see in the real world. Okay, so these are representations. So it represents things that are too large or small or complex to see in the real world. And it makes it easier for us to interpret them. And that's it. Now, tomorrow, when we come back, we are going to, one, quickly make sure we're clear on this. I'll just quickly ask a couple questions. I have a practice sheet that I want us to do. It's going to help us work on independent variable, dependent variable control groups, and then we will start the bubblegum lab, okay? So bubblegum lab.